Anybody know this one? Know this song? Interesting. How are you? Good, how are you? You're gonna have to put that somewhere. Then you know that song? A seal. Crazy. Good day. Oh, they brought it. Did you check with make sure your neighbors could do the date? That's the 7 factorial over. So I figure out 7 factorial? Now to do this, I'm going to cancel which one should I cancel? The big one, right? So first cancel the big one, so it's just this. And then 7, add 2 goes into 6 3 times, resulting in today. Or yesterday plus 1, of course. 21st. Okay, so the last class we finished pretty quickly and everyone is basically finished their homework. Let's see if we could do that today. We'll see. I'd like you, before we talk about that definition, go ahead and do example for us, a quick warm up. Pardon? Oh, is that is me? Thank you. Page 18, yes. Right there, like. Oh, yeah. Did you discuss? I guess you did. Can't call on Nico if he's not here. Can't call on Amir. Don't know what to do with that. Sophia C, what'd you do, for example? 4. And where did that come from? Nice. You have 2 possibilities in each one of these. And last time we just talked about that multiplication property. We take all these, multiply together. 2 to the 5th. Could you calculate what 2 to the 5th is? It's 32. Are we good? 32 different ways to make a code with 2 digits. Okay. I don't know what that's after that definition. Today we're talking about 2 different types of groups, permutations and combinations. How many of you have studied permutations at all? Okay, so this will be a little bit of review for you. And we're doing it from the beginning. So by definition, a permutation is an ordered arrangement of R objects chosen from amongst N objects. So we're just ordering things. So example 5, going right to it. You have 6 framed Pokemon cards that you'd like to display on your wall, all in a single row. How many different arrangements can you hang them? In how many different arrangements can you hang them? And you kind of have a visual representation. 3, 4, 5, 6. Then the first space, what number would go there? 6. The second one? It's 5 because you used one of the ones already. And then the next one, of course, 4, 3, 2, and then you have no choice for that last one. So this could be expressed as 6 factorial. That's how many ways to rearrange 6 different items. Try example 6. 5 people from your classroom today. There are 14 of you. 14. Got it?
Yeah.
And it is working. There's no indicator, but it's working.
Oh, okay.
Sure. What's the word indicator light saying?
It turns yellow.
Oh, okay. Yeah, 14. No, thank you. Okay, example 6. Would like to tell us what they did? Sahana.
There's like five options for like where they're gonna spend. So the first one is like 14 options to anywhere like 13, 12, 11, and 10, since you're using that one person each time. So it's just like on the top, there's 14 factorial, but since there's only 5 spots, it would be 9 factorial on the top, because that right there is just 14 factorial, except for the like canceling out 9 factorial.
So you're making it kind of a math equation here. Okay, because I think we're done with this 14, 13, 12, 11, 10. Yes? But I love what you're doing, like connecting it to the fractals that we had before. And so you said you could rewrite this as a fraction like this, 14 factorial over. Does that make sense if that's equivalent? No? Did you actually multiply these numbers out? Good, thank you. Yeah, don't multiply these numbers out and unless you're compelled to do so for some reason, like it says to actually do that. If this were a test with no calculator, please make sure to leave it like that. And if you want to, maybe you could do something like, I think you could put those two together. Do you know what 12 times 11 is? 12 times 11 is 132. So maybe you could do those 3 times 14 times 13, but really you're done right there. That's calculator ready. There's no need to put any of that together. You would not be done right here. If you left that as a fraction, it would not be simplified enough. I do want to see that 14, 13, 12, 11, and 10. Any questions? Oh, yes. Make sure that's circled the one you want me to look at. Because if this is the last thing I see, then maybe that's the only thing I'm going to see. So just be clear. Yes, Levi. Will the test be calculated? Probably not. We'll know more in days to come. Yeah, exactly. Just sleeping like that is perfectly fine. And of course, this order means that if 2 people switch places, that counts differently because the order does matter for a permutation. That is the definition. So, Sahana, you hit the nail on the head right here with this theorem. The number of arrangements of n objects using R is less than n of them, in which Objects are distinct. Repetition is not allowed, and order is important. It's given by this formula. N factorial over n minus r factorial. Like that 9 from the problem we just did just came from that 14. So I'll put here 14 people. 14 minus 5 gives us that 9. And so this is red. Permutation. Of n, choose r. Of course, r has to be smaller than n. And n is a big group you're choosing from that group. It has to be less than or equal to n. So this is one way you'll see it. This is the way I'll probably write it. It's the easiest to type for sure. You'll also see it this way. That is, it still says a permutation of n, choose r. And sometimes you'll see something like this. Permutation of n, choose r. So try these two, example 7 and 8. Yeah, check in with your neighbor once you're done or stuck with each one.
But then.
Does this make sense?
Yeah. But there is only five letters. Oh my god, never mind. Like, yeah.
Not allowed.
For example, like can you go to a letter? Okay, I know, like, so what is annually? Like, so like you have them two letters. But you can't go more than 5. Oh, okay.
If you get more than 5 with repetition, that would be impossible.
And then. Oh, yeah. Oh, yeah. No, but. Oh, I can. Yeah, yeah. You can make like words and five letters. Like that. Yeah. That's a problem. Yeah.
Are we ready? Your 10 seconds. Okay, Kimmy, can you help us with number 7, please? As an example 7.
So I did and then the
Nice.
first two have two letters. So the first one has 26 options, and then since we need one, the next one has 5. And then 10 possibilities, and then 10 25.
Is it actually 10? Thank you for including 0. Perfect. Should we multiply any of that out? Unnecessary. And of course, this is multiplication. We're not just going to leave that blank. Any questions? Could this have been done using permutations? Let's think about this. Isn't this just the permutation of 26 choose 2? Does that make sense? And then this would be the permutation of 10 choose 3. You can get the exact same thing, multiply those together, and then you have your answer. So it's just formalized way of saying, I think the first what you did is perfectly intuitive. That's what I would do as well, but just trying to connect the two, get an idea. Just an ordered arrangement. Number 8. Who'd like to tell us what they did for this? Levi.
There's not a problem with it. I just gave it five factorial.
Okay.
And for the second part, remember for anyway, so there's five factorial, 5.4,
So I'm sorry, how many ways are to make 4 different letter?
Like 5.4.
Oh, because it's also 5 factorial.
Yeah.
Oh, that's interesting. Okay. And then you did 3 letters too?
3, yeah, so 3 over 5. 3.
Okay.
And 4, sorry, 3, 5.4.
That's fine. Are we good with this? What's that? Oh, 5 times 4. I think that's what you said. I don't know. You 2 words. And we're taking all of these and adding them together. Any questions? Yes. Oh, so the first letter for which case? The 5, 4, 3, 2, or 1, or all of them? Good question. For this 5, and I'll make 2 different sets. There's definitely 5 choices that we have for that first letter, correct? The second one, there's 4, because we used 1, 3, 2. And then there's 1 left over. So with this one being 5, I guess we're just choosing 4, 4, 3, and 2. Yeah, with no choice and then not having to choose, it kind of leaves the same number of options, which is kind of counterintuitive. You think that it would decrease every time. So the first 2 are the same. Could we have used permutations here? Yeah, the first one would be permutation of 5 choose 5. Second one, 5 choose 4. I think working that out, would that be equivalent? Like if you did the math for both of those? That's interesting. And the permutation of, here we have 3 letters, 5 choose 3. Permutation of 5 choose 2. And you don't really have to say permutation of 5 choose 1. There's just 5. But permutation of 5 choose 1 would be exactly the same, wouldn't it? Could you visualize that? Because it's 5 factorial over 4 factorial, so everything counts, but okay, so distinct versus indistinct has nothing to do with smell, just so you know. Distinct means that you could tell them apart from one another. And in the word count, there are 5 distinct letters. But what if you get to something like, we're going to skip block? How many words can it make? Words can you make from the word Nancy? You might think it's 5 factorial, but yeah, it has the ends, and if you switch ends, it doesn't make a different word, does it? What we have to do is divide out all the different permutations of the ends. Since there's only two of them, we divide by 2 factorial. So 5 times 4 times 3. Would I expect you to multiply that out without a calculator? Yes, I think it's reasonable. Let's do math teachers. Go ahead and do the other ones, please. I don't know what this is. Let's do 6. Let's use all the letters. Make sure your neighbor got it. I'll call on someone for the next one.
Oh my God, is that A? Oh my God. Yeah.
Okay, Holden, help us out with banana.
Banana. Well, no, there's a six-letter word. Six possible. So 6 factorial.
Okay, let me see if I can figure out how to use my equipment. 6 factorial.
And then there's 2 times, so it's going to 2 factorial. And there's 3 is 5.
Are we good? Is 2 factorial times 3 factorial equal to 6 factorial? No, please don't do crazy things. Were you able to boil this down to a single number without too much? 60. Do we agree? Did I go through the mechanics of that or everything? Thank you. Would everyone hold up the answer for the last one? Yeah, of course. And if we were to do this mathematically, it'd be 5 factorial divided by 5 factorial, which is already very intuitive. That's one way to make a word. No matter how you repeat, how you mix it up. So that's what this is. This other thing, a permutation of n objects that are not distinct. You have to divide through by the repeats. I give you a moment to do numbers 10, 11, and 12. Examples 10, 11, and 12. I'm calling 3 people for these. Take everything in before I start calling. Make sure no careless errors. Okay. Example 10. Henry, help us out. Okay. Times 2 factorial, you said? Do we agree with this? Okay, let's simplify this together. Which one should we cancel? The 3 factorial, the 2 factorial, or 2 factorial? Always the biggest one. So that leaves us with 9 times 8 times 7 times 6 times 5 times 4 over 2 times 2. What should I do? Yeah, let's do that. We have 4 on the bottom, 4 there. Should we continue? Okay. How many if we were to multiply this out, what would the last digit be? Would you check in with your neighbor? What would the last digit be? Don't call it out though. Can you show me the last digit? It is 0. How do we know that's gonna be something, 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 0? Yeah, because there's a 10 as a factor. Does that make sense? And that's what makes yeah, there's a 30, yeah, there's a 60, but there's a 10 that's a factor. And we don't see it directly, but we could see that 5 times one of the 2's and any of the other numbers would result in a 0. Does it possibly end in 2 zeros? We do the work to check that out. We need another factor of a 10. Is there another factor of 10 up there? No. There's a single 5 with a 2, and then there's no other 5 in there, so it's another 0 at the end. Anything. So we would just leave it like this. Mississippi, the most fun word to spell, don't you agree? Most fun word. If you learned in what grade did you learn how to spell Mississippi? Second-ish. I just remember taking great pleasure with spelling that word. Yeah. Yeah, it has a rhythm to it. Makes me want to visit the state. Levi, help us out. Mississippi. Okay. Okay.
And then, there's,
Does that make sense? Yeah, so this 8 cancels with this 8, the 6 cancels with this 6, or the 48 cancels with 48. It's the same thing. Please discuss how many zeros this ends with. How many zeros does it end with? Just one. Yeah. There's another 5, but no other 2's to make that 10. And this one. Flags, interesting. I don't really know what to do for this. Okay. Should we do this one? Should we multiply this out? I think we should. Because 8 is just 4 times 2, isn't it? I want to see that too, so I could put it with the 5, and then I'm just left with 28, right? So 280. Are we good with that? Or 40 times? Let's say it again. 40 times 7 should be the same thing. Yeah, I like to find the tens personally, but I think this one is not too difficult. It would be reasonable for me to expect you to finish this to get an actual number So when I say to use your best judgment, like if you're gonna take the time to come to the ask me in front of everyone if you should do this, and I said you use your best judgment, your best judgment should point to yes. I'm not gonna tell you that. You have to use your judgment. And if your judgment has failed you, I'm sorry to hear. It's just, live and learn. Live and learn. Judgment has failed me many times. Better person for it. Combinations. Here we go. Finishing the concept. If order is not important, the number of ways selecting groups of objects becomes much smaller in general. Let me say this again. If order is not important, that's the key, the difference between permutations and combinations. In combinations, order is not important. Like, so here's the example. There are far more ways to pick a president, vice president, and secretary for a group than there are just picking 3 people for a group with no attention to their roles. Does that make sense? Like so imagine that example that we had from earlier with 5 people. If each one had a particular role, then that order definitely matters. But if we don't care about the order that they're standing in or what they're doing, then it's just a group. And when they switch places, it's the same group. There's not a different number in that combination. Okay. So theorem, here we go. Combination of n choose r. So here's one way of denoting it. Here's another way of denoting it. This is another way of denoting it. You just see the parentheses around that n. I'm not gonna say n over r because that makes it sound like a fraction, but the n above the r. But this is a formula to figure out what that combination is. The combination of n choose r. There is one more way to write this, of course. Combination of n choose r. So if I want to do 3 choose 1, sometimes you just leave out the combination as well. It's much more common. So just 3 choose 1. That would be 3 factorial over 3 factorial over 2 factorial, just like with permutation, but we also have to put the 1 factorial. Yeah, that's the difference in calculation. And that 2 plus 1 on the bottom has to add up to 3. I think that's quite easily done. Maybe that's just me being strange. I'm not sure. B, C, and D are for you. What did you say you already did on? Remember when you're done with each one. You done? You got something? I didn't hear anything. So I think it's work on. So how can you help me with B?
Two factorial times 8 factorial.
Okay.
And then, you cancel the 8 factorial to the left with 10 times 9 is a 2. And then since, I just divided 10 by 2, so I got 5 times.
Are we good? Thank you. Was C very different from that other one? It's the same. Interesting. D. Ria, can you help me out with D, please? Times 1? That's just 1. Is this true? Thank you for remembering that. So this gives us a value of 1. Yay. Any questions? There's a typo or an omission in 15 from a group of 7 friends. I'll give you a moment to do 14, 15, and 16. Neighbor, as you go.
No, I understand. Yeah, I ordered. Yeah,
14, 15, 16.
Whoa.
What?
Oh, no.
Yeah. I can go.
We ready? Yeah, ask that was 14. So it's factor over 4 factorial. And but on the bottom it's also right now it's pretty. Oh, I'm sorry, frozen. This way we care about, or we need to divide by more. We also. So that's a W. Okay, good. Okay, so this is what we start with. And can you help me out with that one, please, Sophia? I asked you that. So it's saying, it's a smile. Okay, example 15, Z. That's the. Why is it a combination? Still 3 people. There's different ways to select it, but you can say, okay, this time you drive, you pay this window, we fire trucks, different from you drive, you wait for fire trucks. So we're covering it. Each one has the goal, then we cover it. And it's, you're right, it's kind of for the word. Still a group of people, maybe anyone that will do that same thing. But because it's so specific. Okay, please. One, two faculty and 3 students, 6 faculty, and students. So this would be. Six. Oh, writing the. Sounds like you're doing this, aren't you? Okay. So this is still red, a combination of like tension. Everything else is multiply, is that if you're gonna do it? Multiply everything. What do you want to multiply? Or what do you have to say about it? Multiply. Comes down to, I'm super quick, I asked myself for the fact. It's, I don't think it's maybe intuitive, but how do we fit this together? So, no, that's. I think it comes down to the photo. It's had to. Back with the numbers. And we did this. So how many different ways to keep back with the numbers? That's one of the numbers. So it comes down to the count. Number of possibilities. Faculty. Example 17, you're not going to do in class today, maybe tomorrow. I think think about it. But before we do that, I want to go back up to example 6. 6, that one I wanted to. Oh, I want to do this one. Example 7. Example 7. If you were to multiply this out, please discuss the neighbor how many. Look at it. Remember example 7. How many zeros at the end of this product? 3. How do you know it's 3? What's that? It says again?
Even with the 5 second 5.
It has plenty of tips. But we already have one. Wait, so you kind of didn't actually do this, but you're like something, something, 0, right? Okay. But what if this would have been 35? Just be careful. Because 25 is special just because it has a 2 5 in it. So we're able to use it 2 times. Nice. Yeah, so just a tiny bit of math sense. Any other ideas? So homework